Hello, children. How are we doing today? Hope everything went all right for you. Either a lot of you haven't got to it yet, or that lesson was really, really easy, or a lot of you just didn't care about me working problems. So, either way, I'm all good with that. I got one person, or I should say, whoops, I'm sorry, wrong thing. I got one person that wanted number 64, and then somebody put an asterisk by it. So that's two people I got out of 30 that needed number 64. So I'm guessing the rest of you 28 got that figured out. Come on now. I should have quite a few more things down here, probably even more than number 64. But if the rest of you got that, then I must have done a heck of a job. So pat my back. Here's 7.1, number 64. I haven't even looked at it yet. This scares me. Hopefully these formulas weren't too bad. You're going to find some formulas today in today's lesson that are going to help you find the summation of some of these things. It's going to help you out. And let's see here, 63, 64. You want to save $500 for a school trip. You begin by saving a penny on the first day. You plan to save an additional penny each day after that. For example, you'll save 2 pennies on day 2. This is the old penny problem. I'll be darned. There was an old thing all the time growing up. Would you like to have, I think, $1 million or a penny a day and just double it every day for, I think it was just 30 days. And of course, a lot of people wanted the $1 million and maybe just 100,000. I don't remember, but a penny a day, you're going to see, I'm sure in this problem, see how much money you're going to have after 100 days. You're going to see how much money you're going to have after 100 days. It's crazy. So let's see what it says. It says, how much money will you have saved after 100 days? How many days do I need to get $500? Okay. All right, so let's look at this. A penny a day. So the first day is a penny. The second day is another penny, so it's 2 cents. The next time it's 4 cents because we got 2 pennies, sorry, 1 penny, then 2 pennies, then 4 pennies. This is going to be 8 pennies. So we're not saving very much yet, but then we're going to go up to 8. So let's see, what's the next going to be? 16, because we're just doubling this each time. So look, this is exponential. This is going up exponentially. 32 cents. So you can see 1, 2, 3, 4, 5, 6 days. We don't even have $1 yet. Getting close. 30, 45, 48. We're getting close to a half a dollar. But now you can see right here, boom, 64. Right? This is jumping up fairly quickly. So let's try to write a formula for this. See if we can come up with one. I'm going to kind of, let's see. I can see that this is exponential. And this kind of starts getting hard. But this is, this is 2 times 2, 4 times 2, 8 times 2. So this is a 2 to the, here's what I'm going to do to this. I'm going to make this 2 to the n minus 1 because this is the 1. And then I'm going to divide that by 100. You'll see that? That's kind of interesting. I bet y'all are probably, some of you guys are probably trying to figure out how to do the 0, 1. And there may be another way to do this, but I just kind of cheated a little bit here. Because this is n minus 1, so this is the first term, right? Second term, third term, fourth term, or 5th day, 6th day, and 7th day. So 1 week, and we're just up to 64 cents. Now remember, this is not just 64 cents. You got 64 cents plus all these other days, right? So we got 3 cents, 7, 15, 31, and now what, 63. Now we got $1.27. After 7 days, you got $1.27. It's looking like you should have jumped on that big money, right? But 2 to the first, 1 minus 0, so 2 to the 0 is 1, and 1 over 100 is 0.01. Second, 2 minus 1 is 2. 2 to the 2 is, 2 to the 1 is 2. So this looks like this works. Okay, so I need to sum this up. I think they want it for how much money will you have saved after 100 days. So I'm going to cheat, guys. I'm sorry. I'm going to cheat. N is equal to 1. And here's my formula, 2 to the n minus 1 over 100. And I want 100 days. This is 7 days. And I'm not doing all this. I'm going to cheat. And so let me turn off that light, and that might turn off that reflection. I got to turn off this other light. Here, hopefully that'll work. All right, let's turn this on. This is my calculator. I don't use it very much. Look at here what I got. Oh, y'all can't see that. That's blurry. I need to dim that. I don't know how to dim that on this calculator. Here, I can do it on this one. Where's my TI-84? 84 will do this too. I don't know how to dim this thing. Probably my settings somewhere. Handle status, document settings. Sorry about this. All right, here's my 84. Math. Number, complex. It's around here somewhere. There it is, summation. Ha ha! Summation. Boom, enter. Look what I get to do. I get to plug all this stuff right in. X equals 1. And then we're going to go over here. We're going to go 100. And then we're going to go 2 to the x minus 1. And this is all over 100. Now, I don't know if you're supposed to do this with a calculator or not, but that's what I'm doing. Holy cow, look at that number. 1.26. It's not $1.26, kids. That's times 10 to the 28. 1.26 times 10 to the 28 power. That means, oh, go away. How did I do this? Go back up here. That means I got 28 places after this. I think that's right. That's a lot of money. That's how these exponentials work. Our mind does not think exponentially very well. That's a lot of money. How much am I going to need to get 500? So let's go back. Let's see if I can do this. I don't think I can do this. And just start hunting and guessing. Maybe I just start hunting and guessing. I was trying to figure out how to graph that. Let's go up here. Whoop. Go back down here. Go over here. Delete, delete, delete. Let's just look at 10 days. I know about what I got 10 days. 10 days is just $10.23. So I'm going to hit second enter again. And then I'm going to go back here and change that 10. Let's change it to 20 days. See what we got after 20 days. Look at there. That's holy cow. So we know, look at how fast it goes up from 10 to 20 days. Now we're at $10,000. So let's just see what happens in 1 month, because that's what I've always remember hearing was 1 month. And maybe it was $100,000. 30. 3, you're over $1 million. It's 10 million. Yeah. Yeah, so you're given $1 million or a penny a day and double it for just 30 days. You want the penny a day and double it every day. I'm sorry, I'm playing around here now. Second enter. I would not ask you guys to do all this stuff, and I'd show you all this at some point. We're over 10. Let's do 13. I could cheat and just look at the answer. I need more than 13, so let's go 16. 16. You guys got the answer, so I'm too many, so 15. Second, enter, and I'm just playing with numbers here until I get there. 15. Is that too many? Nope. So by day 16, I'll have enough. How many days must you have saved in order to earn $500? I got to do 16 days. Explain how you use series to find that number. I don't know if I really did use series. I kind of did. I mean, I used the summation and the series. I used that formula. If this was a question I'd ask you guys to do, I just want this thing right here. And at some point, I would show you how to do that on the calculator. It's under. Now this one's not as bad. Sorry about this reflect. That's why I don't ever do this that much. It's under the math key. Whoops, where you at? Math. And you go down to summation. And this, you may have to have an updated calculator to do it. I don't even know if a regular 84 will do that or not. It will, but you may have to enter some certain data. This one does it really nicely also. New document, don't want to save it. Add calculator. And it's just right here, enter. You can't see that. There you can. Enter the same type data. This one now you can actually enter like an N because I have a whole alphabet down there. Same type of deal. Okay, y'all don't care. A lot of this stuff can be done on a calculator, okay? Oh, I'm about ready to lose my voice. All right. I want 7.2. If there's any other questions that you guys need me to work out, let me know, and I'll try to do that. I didn't have anybody jump on today, and nobody got on my Google Doc my Google Hangout or nothing like that. So I'm guessing I just did a heck of a job. All right. 7.2. Arithmetic. I always said arithmetic, but it's not really matic, it's medic. So arithmetic sequences and series. In an arithmetic, and again, I'll say arithmetic just because I always have, arithmetic sequence, the difference of the consecutive terms is constant. And this constant difference is called the common difference because it's a common number, and it's denoted by D. Okay, so here's example number 1, and I'm not going to write any of this stuff down. I'm just going to look at the difference between these. So between -4 and 1, that's 5. Between 1 and 6, that's 5. Between 6 and 11, that's 5. Between 11 and 16, that's 5. So this is an arithmetic sequence. It's not a series because it does not have plus signs. It's an arithmetic sequence, doesn't have the plus signs, and its common difference is 5. Okay? Easy enough there. 3 to 5 is 2. 5 to 9 is 4. It's not already, boom, it is not an arithmetic sequence. Okay, it's not. It's going from 2, it's going to 4, it's going to 6, it's going to 8. Now, something interesting to note is in the, can I call it the second layer? In between 2 and 4, that's 2. In between 4 and 6, that's 2. In between 6 and 8, that's 2. Y'all see what I'm saying? When I can't point and do that. 2, 4, 6, 8. Those were the D's first. But in between the second layer, so this was the first layer to give me the 2 and the 4 and the 6. This is a 2, that's a 2, and that's a 2. Y'all see that? And that's something special too. That tells me that the original was exponential. Something type of an exponent or exponential type is going to get me this value. We don't care. I'm sorry. That's just, it's not constant, so the sequence is not arithmetic. All right, so here's 2 formulas that you're going to need to know, or they call them rules, formulas, whatever you want to do. The nth term. Now remember the nth term. It could be the first term, it could be the second term, third term, the 20th term. All right, the nth term of arithmetic sequence with the first term a sub 1, so making sure a sub 1 is the first term, which most of the time it always is, and has a common difference of d, is given by this formula. All right, so let's look at that. This is a sub n equals a sub 1 plus parentheses n minus 1 d. All right, here it is. That's the formula, okay? Where n could be whatever term I want. All right, n is whatever term I want. If I want the 20th term, then that's 20. Okay, a sub 1, well, what's a sub 1? That's the first term. Okay, that's the first term, whatever it might be. N, well, that's whatever term I want. That's the same n as this right here, that 20. And then this d, okay? And that d is that common difference. This started way back when. Old guy got in trouble in math class all the time. And what his teacher would do for punishment is he told him that he needed to add the numbers 1 to 100. That's what his punishment was. So you guys, y'all get so lucky. Y'all don't get anything like that. I'm nice to you guys. But that was what his punishment was. Way back in the days, his teacher told him to add from 1 to 100. So this is what this kid did. 1 plus 2 plus 3 plus 4 plus 5, right? 90, let's just do 90, 91, 92, 93, 94, 95, okay, 100. Well, this is what he figured out. He said, why am I adding all these up when I can just add these two up and get 101? And when I can add these two up and get 101, 99 and 2 is 101. 98 and 3 is 101. So he just figured out how many 101s he had and just multiplied it. Interesting, huh? That's how this formula kind of came about. I apologize for that. That's not how this formula came out. This is the summation. This is not the summation. Forget what I just said. This was true, but it's not for this. We're trying to figure out how this came up to this. This has nothing to do with it. It makes sense in just a second. All right, so here we go. Write a rule for the nth term, then find a sub 15. All right, so what do they want us to do? Let's cover that up so we don't see the solution. So here we go. Example number 2. Example 2. 4, 9, 14, 19. I'm going to go ahead and do the other one. 60, 52, 44, 36. All right, so the first thing I need to do is figure out that difference. 5, 5, 5. Better make sure they're the same. If they're not the same, it's not arithmetic. Okay? If it's not arithmetic, it's something completely different. We got to go with it. So we're going to write the formula. So we'll just do a sub n is equal to a sub 1, which is nothing more than 4, plus n is a constant, minus 1, and then d is 5. Now, guys, we'll simplify this, all right? Let's simplify that. Distribute that 5, okay? And I really have seen it to where the d is in front of that, like you guys would normally see that, distribute the d. Doesn't really matter if you put the d out here or the d right here. Okay, so you'll see me switch that up after a while. 4 plus 5n minus 5, and I can put that 4 and the negative 5 together. And so that'll be 5n minus 1 equals a sub n. Now they want me to find the 15th term. So the 15th term is a sub 15. And I just need to plug in 15 right there. And 15 times 5 is 75. Minus 1 is 74. Okay, and that's a whole lot easier than trying to go out here and trying to do this 15 times. Just keep adding 5, add 5, add 5, add 5. Just use that formula. All right? Everybody good there? This one, we got to figure out this difference again. So this one is 8. Let's see, 4, 5, 6, 7, 8, 9, 10, 11. That's 8. All right, and this is 8. That's good. And it's kind of like a negative 8. All right, because it's going down. I think they call it a recursive. I don't know, it's been a year since I've seen this. So write the formula. A sub n is equal to a sub 1, which is 60, plus, and then my difference is negative 8, n minus 1. Okay, again, I told you I'll start putting that d right there. Here, get me out of the way. Go up here. There we go. Notice how when I look up here at it, my eyes are not looking at y'all anymore. Negative 8n, that's plus 8, 60, a sub n. A sub n equals 68 minus 8n. All right, and if I want the 15th term, I just want a sub 15. 68 minus 8 15s. 8, 9, 10, 11, 12. That's negative 120. Negative 120 and 68. That's going to be 2 and 52. Negative. Uh-oh. Sorry about that, guys. All right. Everybody good there? Okay. Arithmetic sequences. Let's see how we did here. Well, that's not how we would write it. I put 5n minus 1. I don't know why they did that. Negative 8n 68. It doesn't matter which order you put that in. Negative 52. All right, I got that right. Okay. Right 8. Now, this is going to start getting hard here, guys. It's going to start getting harder. One term is a sub 19. So one term, how about that being the 19th term? That's not just one term. That's the 19th term is 48. And the common difference is 3. Write a rule for the nth term. All right, write a rule for the nth term. Well, guys, in order to do that, I got to know what a sub 1 is. All right, I got to know what a sub 1 is. So I'm going to go to my formula right here, and I'm going to just plug in what I do know. Sorry, I do know a sub n is equal to a sub 1 plus d n minus 1. That's my formula, okay? And again, I don't know why they put the d at the end of that, but this is what I do. All right, I don't know what this is, but I know that when I do a sub 15, it's going to be a sub 1 plus, and I know that d is 3 because they told me that, n minus 1. Whoops, that's 15 because they know me the 15th term. And they told me that this is actually equal to, I'm sorry, I messed up here, 19th. I got the last problem in the way. So this should be a 19. I was wondering, y'all probably wondering where in the heck I was getting that 15 at. Well, this is gone now. I don't need that because 48 got plugged in here. So here's what I got. I got a sub 1 equals, let's see here, 57 minus 3. I could have done 18 right there. I probably should have done that first. Equals 48. This is a plus sign. I'm starting to be a little crazy here. And 57 minus 3 is 54. 54, subtract 54 from both sides, and therefore a sub 1 is equal to 8, 9, 10, 11, 12, 13, 14. 6. Negative. Well, now I know my first term. So now I can write the rule. A sub n is equal to 1, a sub 1, which is negative 6, plus d, which they told me is 3, n minus 1. Why am I putting n back in there? Because I want a general rule. Okay, so we'll distribute that. Negative 6 plus 3n minus 3, 3n minus 9. A sub n. Oh, and it says graph it. I don't want you to graph it. No graph it. Here's my answer. If I was to graph it, let's talk about it, okay? These should be linear because of common difference. And notice that these points are not connected. These are not continuous functions. These are what we're going to call discrete functions. They're not continuous. There's no way to get a 1.5 term. There's no way to get a 1 3/4 term. There's only the first term, there's only the second term, there's only the third, fourth, fifth, sixth. So don't connect those with a line if they have you graph it. I don't want you to graph it. There's no need to do that. All right. Question over that? Doesn't matter if you have one or not. I can't hear you. Oh, this is going to get real hard now. That wasn't too hard. A sub 8. A sub 8 equals 21. A sub 27 equals 97. Find a rule. Wrong way. Find a rule for the nth term. Well, that's the only thing I have to go off of. I know that A sub 8 is equal to A sub 1. I don't know what that is. Plus D. Well, crap, they didn't even tell me what D was. Now, some of you guys might can figure this out, but I'm just going to go with this. D, and then I'm going to do N, which is 8, minus 1. All right, go with me? And so this is going to be 21, because that's what A sub 8 is 21, equals A sub 1, which I don't know what it is, plus, and this is 7D. Okay? Now, I'm going to go here to this formula. And I know that A sub 27 is equal to A sub 1 plus D, which I don't know what it is 27 minus 1, because it's the 27th term. And now I know A sub 27 is 97 equals A sub 1 plus, and that's going to be 26D. And guys, right here, I got two equations with two unknowns. And so I need to solve one of these equations for one of the variables. And I don't think I want to solve for D, because I'm going to tell you that's going to get nasty. So I'm just going to solve it for A sub 1. 21 minus 7D equals A sub 1. Substitute that in. So 97 equals, not A sub 1, but I'm going to put 21 minus 7D. And then I'm going to do plus 26D. It's getting dark. Here we go. All right, now we're going to solve. That looks much better here. Subtract 21, which is 76. Negative 7, let's see, that's 19D. Boy, I hope that divides well. 4, yeah. D equals 4. Now, I still got to find what A sub 1 is. But I think what the easiest thing to do is plug that in right there. Remember how when you substitute, you go back and plug in back into the original? And so 7 times 4 is 28. 21 minus 28. 21 minus 28 equals A sub 1. And that'll be negative 7. So now I get to write my rule. A sub n equals A sub 1 plus D n minus 1. And we'll simplify that a little bit. A sub n, negative 7, 4n minus 4, A sub n, 4n minus 7, 8, 9, 10, 11. And if you really want to check yourself, plug in 27, and you better get 97. And plug in 8, and you better get 21. If you don't, you didn't get it right. You don't need to check the back of the book. Yay, they didn't put it in order, I did. All right, that is arithmetic sequences. Now we're going to do arithmetic series. Remember the difference between a series and a sequence is the pluses in between them. So arithmetic series, the sum of the first n to s of n. To write the rule for s of n, you can write s of n two different ways and add the results. So this is the one I was talking about, adding the 1 to 100. Right? Add the first term to the last term. Add the first term to the last. And there's 2 of them. Don't worry about it. Here's the formula you need. Okay? Here's the formula. Let me turn pages. All right. S sub n, you know that's the summation or sum of them. They don't use sigma here. N, and then we'll do a sub 1 plus a sub n over 2. All right? And that's where that came from. That's the same one, adding the 1 to the 100. Okay? You get 101, but there's only half of those. So that's why you got to divide it by 2. So example 5, I'm not looking at that one. Here's a house of cards. That's a good question. I don't want to work that one. Oh, crap. Then give me one. There's no examples. Besides a word problem, I don't want that. Well, you're just going to plug and chug. Here we go. Guide to practice. Here's one. All right. They're giving me the summation. N or I is equal to 1. Again, I like the n's. 2 plus 7i, and we're going up to 12. Okay. So this is whatever example this is. Okay. So find the sum. So we would plug in 1, plug in 2, plug in 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and add all those numbers up. Well, now we don't want to do that. I kind of showed you how to do that in your calculator, but we're going to use this formula over here. So n, well, how many terms are there? N is the number of terms. So how many terms are there? Well, there's 12 terms. It's telling me there's 12. So S sub n is equal to 12. A sub 1 is the first term. 7 times 1 is 7. Plus 2, 8, 9. That's the first term. 9. A sub n, which is 12. 7 times 12 is 84, 85, 86 over 2. 86 and 9 is 95. S 12, 95 over 2. That will get that 6 times. And so now we know that the sum is equal to 54 and 3 more is 570. Yippee, yippee, yo. I'm good at math. I don't know if that's the answer or not, but okay, I could check it. All right, now we got the exercises. So 2 formulas is all you need right here. Arithmetic, sequence, and series. This one's probably the hardest. No. This one was the hardest one. And some of you guys can figure out what D is by using ratios. I don't really care how you find D. I just want the formula, okay? Now, I better see some work on some of this stuff. All right, I need to see some work on this stuff. If I just see answers, that effort's not there, okay? This is going to be due on Thursday morning by 8 o'clock. If you don't get it in by 8 o'clock, there will be a reduction in points, okay? I will have it due at 8 o'clock. You guys that don't turn it in by 8 o'clock, there's going to be a reduction in points. Just like in this lesson right here, there's going to be a reduction in points if you don't turn in tomorrow's lesson by 8 o'clock. So get them in, okay? I need to start holding you guys a little bit more accountable. And again, I need to see work, guys. I need to see your effort. That's how I grade your homeworks. I grade on effort. If it doesn't look like it's effort, you are going to start losing points, okay? That's all I'm asking. Just give me your effort. All right. So I'll post this. I'll post the problems I want you to do, and I'll post the book. I'll see you guys, Wednesday night. Click this button. Come on. Click this one.